we're going to start where we left off. We just got done learning that, yes, we have enough Fresnel zone clearance, given the building that we had that we erased. We have enough Fresnel zone clearance, including earth bulge and everything. Now we need to make sure that our system has enough signal to get from one side to the other. Now we're assuming that both sides are the same, meaning we're going to use the same antenna, cabling, and bridge system in order to get from point A to point B. So we only need to do the math one direction. Keep in mind, if your system is not the same, you always have to make sure the weakest side will go the distance, pardon the pun. So let's see how we start. First thing is we have to gather some numbers. We have to know the transmit power of our bridge. We're going to say this bridge transmits 20 dBm, that's 100 milliwatts. Our cable, right here, our cable has a loss of 2 decibels. The same as on the other side, but remember, we're going one direction, so we don't care how loud the other side transmits. It's actually the same. But in order to receive, it doesn't matter. How well you hear has no bearing on how well you transmit. Same thing for bridge systems. But we do have to take into account this 2 decibel loss on the cable. So minus 2 dB loss here. One of the key factors that you have to use a calculator for is the loss through the air. We actually described that in another video, but it's called free space path loss. I use a calculator on the internet because I don't want to go through all the math. It's right there. The loss across an 8-mile link at 5 gigahertz is 130 decibels. We lose 130 dB across this 8-mile link. So we've gathered, so now what antennas are we going to use? That's probably one of our big variables we have here. We're going to start, and I don't know yet, we're going to start with a 10 dBi antenna. 10 dBi on both sides. And now we have to also know, from our receive sensitivity discussion, we have to know what signal do we want to achieve at the other end. I'm going to say I want to achieve negative 65 dBm. That's going to give me my maximum throughput. There's one other factor that comes into play. It's called fade margin. A fade margin is just like it sounds. We need to make sure that maybe the wind blows real hard and the antenna gets out of alignment temporarily. Or there's a torrential downpour. A lot of people think rain is really bad on Wi-Fi links. It actually isn't, but you could lose a decibel doing that. Not tons, but we should account for a little bit of fade margin. So we're going to call that a 10 decibel loss. We're just going to say we have a 10 dB loss built in that's named fade margin. Now what we do is we just take all these numbers and do the math. We want to see what signal gets into this bridge from the other side. I haven't done this yet, so this is going to be a surprise for me too. We are transmitting at 20 dBm. Remember, the cool thing is dBm, dB, and dBi can all be added and subtracted. There's no conversion. So we're going to add up all our positives first. We have a 20 decibel transmitter, a 10 decibel antenna, a 10 decibel gain on the other side. Those are our pluses. Our minuses are -2 for our cable, -2 for our cable over there. These are all in dB. And then our loss over the air, which is 130 dB. So we have a total loss of 134. We have a total gain of 40. So 134 minus 40 equals 90, what does that, help me out here, 96, negative 96 dBm. So in the end, we've taken all of our losses, all of our gains, done some math. Of course, I could have done this way, minus 135 plus. It was actually more correct. Minus 134 plus gives us negative 96 dBm. So is that right? Is that what we want? Actually, it's 94. I don't know why I'm a math genius this morning. So we're at negative 94 dBm. We're trying to achieve minus 65 dBm to make this link work. We're almost 30 dB off. That's a big number. 30 dB. How are we going to gain that? Well, I'm looking at this, and I've had a little bit of experience at this, so I know antennas. I'm looking at this and saying 10 decibel antennas, really kind of small. So knowing that I need to now gain 29 decibels, I'm going to go out and look for some different antennas. In fact, I know in 5 gigahertz, I can buy a couple of 25. Let's see, we're trying to make up now 29. We can get a couple of 25 dBi antennas. Now, they're going to be physically much larger than the 10 dBis we originally spec'd, but hopefully our customer will be okay with that. If they want the link, they will be okay with it. So now we change our calculations here and here. Let's go blue with that. So now we have 25 in our gain. So we have a total gain of now 70. So a negative 134 minus or plus 70 should take us to what? About negative 64 dBm. We've taken into account all of our losses. Uh-oh. I just realized I made a mistake. I did not account for my losses here. I did not account for my fade margin. My number here is actually 144. I need to actually I have 144 loss now because I have to account for that 10 decibel. So I'm at neg 74. So again, our losses here, 144. I'm at neg 74. So I still need to squeeze a little bit out to make this link work. Now I'm asking for really high signal with negative 65. I have to upgrade some cables. I'm going to upgrade these cables. Bigger cables, better connectors give you less loss. So I'm going to say 0.5 dB of loss on each side. I'm also going to upgrade my antennas to 29 dBi antennas. So now my losses look like this. I have a total of 1 loss between my 2 cables. I'm still at 130 for my free space path loss. My minus 10 for my fade margin. I'm now at negative 141. My gains, I've gone from 25 to 29. So that is 58 plus 70. So I'm at 78 of gain. So a negative 141 plus 78. Where am I sitting? Help me out there. So 2 carry the what? So we're sitting at 22.44. Neg 63. That doesn't seem right, but pretend I'm close here. So we're sitting at about negative 63 dBm. I think I did my math right there. Which now, even including my fade margin, meets our goal. Now, before we even go out to the building, we haven't even actually ever talked to the building owner yet. We haven't had to. We know the distances, we know the heights, we figured out our Fresnel zone clearances, our earth bulge. We did some math. We know what our bridges can do. We know the transmit power, the loss in our cable, the gain that we get here, loss through the air, accounted for a fade margin. This link will work. And the great thing is we didn't even have to pull any equipment out yet. So now with our free space path loss calculations, our Fresnel zone calculations, and doing a link budget, we now have everything we need to go out and deploy a successful point-to-point link.